car is 75% steel, but one missed drop of gasoline can turn a recycling plant into a bomb, and one mercury switch can poison an entire batch of steel. Every year, up to 15 million cars are taken off the road. In the United States alone, that's around 12 million vehicles. But what happens next isn't a trip to a junkyard. It's the start of a fiery rebirth. This mountain of metal holds 14 million tons of high-grade steel. The problem is getting to it. This entire system exists to do one thing: feed the furnace clean steel. If any stage fails to purify the material, the final transformation is compromised. Here's how your old sedan is reborn as a skyscraper. Section 1. The Purge. The journey from road to rebirth begins the moment a car is declared end of life. Before any crushing can happen, it enters the most critical stage. An average car is a chemical cocktail: engine oil, coolant, gasoline, brake fluid, refrigerants. In a furnace, they're fireballs and toxic gas. So trained technicians get to work. The process is a high-speed assembly line, but failure here is not an option. Time per vehicle, under 20 minutes. At this speed, one mistake doesn't slow you down. It ends the run. Technicians methodically drain every fluid. This isn't just about being tidy. If even a small amount of fluid remains, it can trigger a violent explosion or release toxic gas inside the furnace. There is no recovery from that kind of contamination. An average of 4.9 gallons of hazardous liquids are reclaimed per car. Gasoline is siphoned to storage farms, while coolant and washer fluid are sent to separate tanks. But it's not just liquids. Technicians hunt for mercury switches used in older cars for trunk lights, tiny vials of poison. A single one slipping through can contaminate an entire batch of steel. This is a critical checkpoint. Airbags must also be deployed or removed. Their chemical propellants are too dangerous for the shredder, with the potential to cause a blast that can halt operations. The lead-acid battery is removed. Engines, transmissions, and catalytic converters containing precious metals like platinum. A single large facility can catalog over 5,000 parts in a single week. Section 2. Brute force the shredder. The depolluted Hulk, now at 75% of its original weight, is ready for the main event. First, a baler applies immense hydraulic pressure, crushing the car into a dense block. This is for efficiency. It makes the Hulk easier to stack, transport, and feed into the shredder. And that beast is the shredder. This machine is pure mechanical power. Shredders are colossal, powered by electric motors with up to 3,000 horsepower, with sensors constantly monitoring the load for peak efficiency. One of the world's largest can process over 300 tons an hour. That's a car every 15 seconds. The car hulk is pushed onto a conveyor and disappears inside. A giant spinning rotor covered in massive manganese steel hammers and spinning at over 700 RPM is waiting. Each hammer weighs hundreds of pounds. They obliterate the car in seconds. But this violence has a purpose: to liberate the different materials from each other. If the shredder fails at this, every downstream sorting system is rendered useless. Purity becomes impossible to achieve. For decades, the car was a tightly bound assembly of steel, aluminum, and plastic. The shredder's force shatters those connections. In under a minute, a car becomes thousands of fist-sized chunks. The brute force phase is over. From here on, purity isn't improved. It's only protected. Section 3. Intelligent separation. The stream of material exiting the shredder is a chaotic mix of metal, plastic, foam, and fabric. The goal here is purity, and the tolerance is unforgiving. Steel mills demand scrap that is over 98% pure ferrous metal. If contamination exceeds that 2% threshold, the entire multi-ton batch of steel can be rejected. The first and most powerful sorting tool is a magnet. As the material tumbles down a conveyor, it passes under massive rotating magnetic drums. The magnets lift all the iron and steel fragments, the ferrous metals, out of the stream. This recovers about 70% of the car's original mass. What's left is non-ferrous metals, like aluminum and copper, mixed with non-metallic waste the industry calls automotive shredder residue, or ASR. Here's the clever part: the eddy-current separator. A magnetic rotor spinning at up to 3,000 RPM induces a repulsive magnetic field in the non-ferrous metals. This repulsion literally causes pieces of aluminum and copper to jump off the conveyor belt into a separate collection bin. For years, the remaining ASR went to landfill. Not anymore. Advanced systems use air classifiers that blow lightweight foam and fabric away from heavier plastic and rubber. Some facilities even use sensor-based sorters with X-rays and infrared cameras to identify and separate different types of plastics. Almost nothing is wasted. But even at 98% purity, one contaminant can still ruin the final steel. Section 4. Trial by Fire. The Electric Arc Furnace. The clean, shredded steel arrives at its final destination, the steel mill. Here, the scrap faces the electric arc furnace, or EAF. A massive bucket dumps tons of shredded steel into the furnace. The roof closes. 3 massive graphite electrodes are lowered into the scrap. Then, an immense electrical current, tens of thousands of amps, creates a powerful arc, a controlled lightning bolt that leaps from the electrodes to the steel. The temperature inside skyrockets to over 1,600 degrees Celsius. Melt time, under 60 minutes. At this point, there is no margin for error. But the process isn't just brute heat. It's a precise chemical operation where one element is a notorious enemy, copper. It's a classic problem in scrap recycling that makes the final steel brittle, and once it's in the molten mix, its concentration cannot be reduced. Lime and other fluxes are added, binding with impurities to form a layer of slag that floats to the surface. Oxygen is then injected to burn off excess carbon. The final chemistry and temperature must be perfect. If they fall outside a razor-thin control window, the final steel won't have the required structural properties. Once the steel reaches the perfect composition, the furnace tilts. The lighter slag is poured off first. It gets recycled for use in road construction. Then, the furnace tilts further, and the pure liquid steel is tapped into a massive ladle. Once it begins to pour, the chemistry is locked in. It bears no trace of its past life as a car. But it isn't finished. The molten steel flows to a continuous caster into water-cooled copper molds that solidify it into a glowing red strand, a square billet, or a flat slab. From there, rolling mills shape it into the final products. Steel beams for construction or sheet metal for new cars. CTA. Next, the aluminum can line, metal moving 60 kilometers per hour, and one timing error can shred the entire run. Want that next? Comment aluminum.